anything before that?
Sir, now we are going live on YouTube.
Okay.
As the limit of Google Meet is only 100, so that's why we are going live on YouTube.
Sure, we'll let. Not an issue.
मोबाइल में क्या कर रहा?
A very gentle good evening to all of you. On behalf of the Qmika Society, we extend a warm welcome to today's webinar, a part of Qmika 25. The topic for today's webinar is From Curiosity to Breakthroughs, Building a Research Career in Chemical Engineering. I am Roshni from Chemical Engineering branch of Batch 2K23.
And I am Harshit Rai from the Department of Chemical Engineering, Batch 2K23. Research is the foundation of innovation, and chemical engineering offers immense opportunities to contribute to sustainability and technological advancements. We are excited to explore this topic with all of you.
And to guide us through this enlightening journey, we are privileged to have with us Mr. Sourav Sengupta, sir, Assistant Professor at IIT ISM Dhanbad. Sir, it's truly an honor to have you here.
Mr. Gupta's expertise in fluid mechanics, transport phenomena, and biological fluid dynamics, along with remarkable journey from a production engineer at Indian Oil to academia, is a true inspiration for budding researchers. Thank you, sir, for joining us today.
Let me quickly walk you through the structure of today's webinar. Our prominent speaker will deliver his talk, sharing his experiences, challenges, and key insights into building a successful research career. This will be followed by an interactive Q&A session where you can ask your questions directly. And lastly, we will conclude the session with a vote of thanks.
So, without further ado, we are delighted to invite Mr. Sourav Sengupta, sir, to take over. Sir, the virtual stage is all yours now.
Yeah. So thank you, Harshit and Roshni, for the nice introduction. So before I begin, I'd like to share my slides. Kindly confirm if it's visible to everyone. Yeah, so I have now shared and I have also gone full screen. So is it visible to everyone? Can you please confirm?
Yes, sir, it is visible.
Okay, thank you so much. Yeah, so welcome you all. It's already 7:03, 7 p.m. I think you must have had classes throughout the day, maybe a bit tired as well, or maybe you had some other events as part of Qmika. So I would not like to bore you, or I'd not like to get into any serious aspects of research in terms of specific case studies or specific aspects of research, because the audience, what I understand, is primarily BTech chemical engineering students. But I would definitely try to have some informal discussion, you can say, on the various aspects that makes a inquisitive researcher, I should say, because after all, no matter whether we are students or whether we are so-called teachers, we are all part of the learning process. You must have all heard about the famous scientist, physicist Richard Feynman. So Professor Feynman once commented that if you really want to learn something very well, if you really want to develop some skills, or if you want to learn a subject very well, you teach it. So basically, we as teachers, it's basically the fact. I mean, the fact remains that we are essentially lifelong learners. A teacher can be successful in his or her career. A researcher can be successful in his or her career when he takes up this profession with a learning spirit. So it is with that mindset only that I'd like to discuss and I'd like to walk you through the journey of a researcher, in specific a researcher who has been in the chemical engineering profession. And also I'd like to talk about some personal accounts, because I think then it would also be helpful for you to relate and connect with whatever I am saying. Okay, before we start, maybe I thought of making this slide that, as I said, I would not elaborate on any specific research area, but of course, if you have any specific questions, I'd be happy to answer. And I'd also like to walk you through my own journey. As I said, as a B chemical engineering student, I could actually, I mean, as I talk to all of you, I can think about my life around 15, 16 years back, when I got admitted to the Department of Chemical Engineering at Jadavpur University, Kolkata, as an undergraduate. I studied there from 2009 till 2013. So I can relate the various confusions that you have as a research, I mean, regarding research as a career, whether to take it up, whether it would be profitable, I mean, whether it would be feasible for you in the long run, how much time it takes and all that. So I'd like to touch upon each of these aspects to the extent possible. But if any query remains unanswered, or if you think any aspect remains unanswered, I'd be very happy to discuss with you. And depending on the format of this discussion, whatever you feel free, it's perfectly fine with me. If you want me to stop at any point of time, and if you want to raise some doubt, if you want to clarify something, it's perfectly okay. If you want me to take up questions at the end, that is also fine with me. Okay, so let us get started with this eternal dilemma, and possibly also a harsh truth for many of us, because as I can understand, for most of us, for most of you also, I think chemical engineering was not the de facto choice, right? So when you had appeared for the joint entrance examination, when you decided to pursue engineering, your choice of branch basically gets motivated by salary packages, so as to say, whatever you see in newspapers, what salary, which engineering discipline can give you more salary, which has better job prospects, so as to say, and things like that. So many of you might have chosen chemical engineering considering that you are getting it at BIT Sindri, which is a renowned college. Maybe you got computer science and engineering as a discipline. You could have opted for a CSE in some other less known college, but you kind of preferred the reputation, the brand name of the college over the discipline per se, and that's why you are in chemical engineering. That's perfectly fine. I mean, many of our decisions in life, I mean, you must have all heard about this statement of Steve Jobs, that many aspects of our life, when we move forward in our life, we are unable to understand why this has happened and why it is so and why it is like that. But as we look back, we are able to connect the dots. So it is only possible to connect the dots when you look backwards. So that's perfectly okay if you have chosen chemical engineering by preferring BIT Sindri over other less known colleges. But the pertinent question, the eternal question remains, that is chemical engineering a really good branch to hold on to in future? Of course, you have got admitted here, so I presume you will complete your degree. You will be, I mean, depending on which year you are in currently, maybe you're in your first year, second year, third year. So whatever be it, you would be here at BIT Sindri for the next 4 years or 3 years or 2 years, or for another year of your BTech journey. But then, is chemical engineering really a good option to hold on to? Let's explore. So I have tried, to the best of my ability, I have tried to categorize categorize some of the doubts that students normally have. So one thing is, of course, in this era of IT boom, in this era of AI and ML, machine learning boom, in this era of information and communication technology boom, Is chemical engineering still a relevant discipline? Is it a discipline worth pursuing in future, or should you move to other areas? Maybe you should pursue MBA. You should get into civil services. Maybe you should go for higher studies in computer science or related disciplines, or maybe you should go for a job in the data science, in the analytics area. So these are some of the questions you always have in your mind, and it's not wrong to have. And these questions have been there in the minds of students for decades altogether, right? Because one thing is, of course, what are the job prospects of chemical engineering? If time permits, I would definitely like to touch upon that aspect as well, because as some of you might be knowing, before I came for higher studies, before I decided to pursue higher studies, I was there. I had a short stint at Indian Oil Corporation as a production engineer for an year. So I have seen both the industrial aspect, both the industrial life of a chemical engineer, as well as I am currently in academics, teaching and researching and engaging with young minds. So I have seen both the sides. But since today's discussion is more about taking up chemical engineering as a research career, so I would mostly focus on the research aspect. But I am free. I'm absolutely okay if you have any questions regarding the industrial aspect. So, what is the scope of research in chemical engineering? What are the ways to pursue a research career in chemical engineering? And how do you really start working on that? Now, as a BTech student, if you have suppose you have decided, if you have suppose you have decided by some mean or the other that chemical engineering is worthy of taking up as your future career, you want to do research. So is there a structured way? Because I would say mostly for the people who are in your first year or second year, that is an ideal time to take these decisions. Not that if you are in your third year or final year, you are too late. No, definitely you are not too late. But if you are in your first or second year, definitely you can plan these things right from this stage. Right at this stage, you can plan. And for those of you who are in your third year or in your final year, for them also, you can definitely think about it, and you can channelize your energy, your activities in a way. So I mean, as a BTech student, is there a structured approach towards developing curiosity and achieving breakthroughs so that we can build a research career in chemical engineering? Let's see. Okay, so maybe some of these information may be cliche for you. For some of you, maybe this is new, but I couldn't resist including this slide whenever I mean, because I'm trying to give you some perspective on chemical engineering research. So let me tell you this from a, because these information and slides, these most of this information these days are anyway, you can get it out there on the internet. So it might be useful if I talk with you in a more informal manner and sharing with you some real life stuff. So the thing is, as an undergraduate, or I should say rather as a class 12 pass out, all of you had some subject as your favorite subject. For some of you it was physics. For some of you it was chemistry, I presume. For some of you maybe mathematics. For a majority of engineering students, generally it's mathematics. And maybe some of you were also good at biology, but you didn't want to pursue MBBS, or you didn't want to pursue biology or life sciences as a subject, but you decided to pursue chemical engineering. But let me tell you, let me assure you, no matter whichever subject happened to be your favorite, chemical engineers work in every area. And I don't say this just like that, just because I am presenting here. It's actually a fact. In fact, to give you the correct perspective, chemical engineering is possibly the only branch of engineering which has the greatest interface with all the basic sciences. The kind of research that chemical engineers do has a lot of similarity with the kind of research physicists do on one side, with the kind of research chemists do on the other side, on the kind of research mathematicians, applied mathematicians do on another side, and the list goes on. The list goes on and on. So chemical engineering is truly a versatile subject. It's truly a versatile discipline. That is the reason you would see that if I mean, I do not know how many of you know this, but suppose if you are studying BTech in mechanical engineering, then as you go for masters, suppose you decide that you would go for masters in mechanical engineering. So in most of the departments, in most of the mechanical engineering departments at IITs and other institutions, you would see that as you go for a masters, you have to choose your specialization within mechanical engineering. So either you have to study something called thermal engineering, or you need to study something called applied mechanics, or you need to study something called production engineering. So whenever you go for masters in mechanical engineering, you have to choose among these 3-4 specializations. If you are doing a BTech in civil engineering, and suppose you are going for a master's in civil engineering, so you have to either choose master's in structural engineering, or master's in geotechnical engineering, or master's in environmental engineering, like that. Suppose you are a BTech in electrical engineering, then if you decide to do masters, if you have to do masters either in power electronics or maybe in VLSI, and there are many other areas. So the point that I'm trying to make, that whenever you are going for these other disciplines, similar disciplines, you choose a specialization right at the outset. But for chemical engineers, and it is also true for computer science and engineers to a large extent, for both these disciplines, chemical engineering and computer science and engineering, very few institutions, very few IITs in India, in fact only I think 1 or 2 IITs may offer, not more than that. Most of the IITs do not offer any specialization in chemical engineering at the master's level. One of the reasons is chemical engineering has so many specializations, so many diverse areas. It is so versatile that it's very difficult to have a single specialization, or 2 or 3 or 4 specializations. It's very difficult, because chemical engineering, as I said, has interface with every subject, with every basic subject that you can possibly think of. Even with medicine, you know that many of the groundbreaking research works that are happening in present times, in the area of medicine, in the area of surgery, a lot of chemical engineers are part of that research team. In fact, I think in 2019, I do not exactly remember the name of the researcher at the moment, but he was the, I mean, she was the Nobel Prize winner for that year in chemistry, and she happened to be a chemical engineer by training. So she was a chemical engineer. She had a bachelor's degree, that is BTech degree, BTech or BS in the US. It's called BS. So it's a bachelor's degree in chemical engineering that she did, and later she worked on areas which are close to chemistry and chemical biology. And because of her innovative research, she was one of the recipients of Nobel Prize in chemistry. You have all heard about the Haber process. I am sure all of you, as a class 11, I mean, when you studied chemistry in class 11 and 12, you all have studied about the Haber process, that is for the production of ammonia. Now, Haber process, if you really look into the books or into the magazines or anywhere, you would see that the method is known as Haber-Bosch process. So it's not just Haber process, it's known as Haber-Bosch process, because this process was jointly developed by someone named Haber, who was a chemist, and a person named Bosch. I mean, his surname was Bosch. He was a German who happened to be a chemical engineer, working at BASF. BASF, some of you might have heard the name. BASF is a famous German chemical conglomerate. So while Haber was responsible for developing, for determining the chemistry, for determining the process that can lead to the synthesis of ammonia, it was Bosch who took up the challenge of converting a lab scale process to a industrial scale process. And it was primarily because of Bosch that ammonia production could be carried out. It could be carried out at industrial scale via the Haber-Bosch process. So there lies the applicability of a chemical engineer. And I do not know how many of you have heard about it. Maybe some of you know that because of this Haber-Bosch process, we are able to sustain on this planet with such a huge population. Had Haber-Bosch process not been there, if this process was not developed, if this was not commercialized, if this was not taken to the industrial scale production level, then the current food production that we have in the world today, it would have been just 2/3 of the current amount. So 1/3 of the current food production across the world is happening only because we learned how to develop ammonia synthetically. We learned how to produce ammonia at an industrial scale via the Haber-Bosch process. So that the food that we are consuming, the food that is being consumed by everyone across the world as a person, most of them are not engineers, leave alone chemical engineers, but we are able to produce that amount of food because we have fertilizers, because those fertilizers have ammonia as the starting material, as the raw material, and ammonia, industrial production of ammonia became possible because of the Haber-Bosch process. So that is the kind of impact chemical engineers have in the world. And I have already said about the subjects, so it doesn't really matter whether you are interested in physics or chemistry or maths or biology. You have something to find. You have something interesting in chemical engineering lying ahead of you. Whether you like to do experiments, you like the lab setup and you want to do something on hand, or you are interested mostly in mathematics, you love coding, you have something in chemical engineering. I, as a chemical engineer, if you see the kind of research activities that I do, I don't want to get into the details, but it's mostly mathematics, it's mostly computer programming, and some bit of experiments. Mostly it's mathematics and computer programming. So it's not that if you have good coding skills, you have to migrate to computer science, you have to migrate to IT. Definitely not. If you are really good at programming, if you have great programming skills, coding skills, as a discipline, chemical engineering has a lot to offer to you. If you are interested in developing something fundamental, if you like fundamental work more, or suppose you are more interested towards application oriented research, suppose you want to develop some product, you want to develop some prototype, no matter which you are fond of, or which aspect you are fond of, or maybe you are fond of both, you are fond of fundamental aspects as well as developing some product, some application out of it, you have something for you in store at chemical engineering, in the chemical engineering discipline. So chemical engineering is, the versatility of chemical engineering is truly unparalleled. No other discipline can come even close. And in this age of age where AI, ML, these concepts are booming, these are becoming a buzzword. Even many people are using it everywhere, even without understanding it possibly. But then, if you are really good at programming, if you have really picked up on coding, you have learned the fundamental mathematical principles, tools with which you can write, with which you can implement AI/ML in chemical process industries, you would be in huge demand. When I say you would be in huge demand, you would be in huge demand from the best of industries, because whenever you are, I would discuss that in the succeeding slides, that whenever you are attempting some research activities, or whenever you are wishing to go beyond BTech, you want to pursue chemical engineering beyond BTech, you have a lot of opportunities, you have a lot of options, not just from an academic perspective. Of course, if you want to teach, if you love interacting with students, if you want to do fundamental research, you love academic freedom, then of course academia is the place to be in. But if you are more of a person who likes to do application oriented research, who wants to see the fruits of research going out in the industry, then also you have a lot of options as a chemical engineer. I don't think I need to mention all this, because many of you might be knowing this, that chemical engineers are one of the highest paid engineers. This might look a bit unfamiliar aspect for some of you, but if you really look into the data, I'm not just talking about India, because I am sure many of you might be having aspirations to do higher studies abroad, and maybe then you want to come back to India and settle for jobs, or maybe you want to go for higher studies abroad and then look for suitable opportunities there itself. So if you look into the data of USA, United States, you would see that chemical engineers, along with petroleum engineers and computer science engineers, are one of the highest paid engineers, because the major employers of chemical engineers happen to be from the oil and gas sector, and they really pay a lot. Refineries and petrochemicals, apart from oil and gas exploration, you have refineries and petrochemicals which also employ a lot of chemical engineers. Indian Oil Corporation, Bharat Petroleum, Hindustan Petroleum, Reliance Industries Limited, SR Oil, Cairn India, and the list is endless. Possibly you know it better. Food processing industries in India as well as abroad. Especially, I can give you one example. Cadbury, all of you know, the company which is behind Cadbury is Mondelez. So Mondelez does a lot of fundamental research, because in the process of making chocolates, the consistency is very important. The texture is very important. People prefer one chocolate brand over the other because of that consistency, because of that texture. This is also true for the cosmetics industry. The texture, the consistency, the viscosity, these things are very important. People might not realize that viscosity is important. For a layperson, of course, they will not know what viscosity is. But in order to make that perfect formulation, many aspects are important, which a chemical engineer understands. So in the food processing industries, in the cosmetic industry, in the beverage industry, so be it soft beverages or hard beverages, chemical engineers are in. I mean, the process is essentially a chemical engineering process, and you need chemical engineers to monitor that and also to make suitable changes. Pharmaceuticals, drugs, medicines, and also the biotechnology sector, chemical engineers are the ones who are in charge. So in refineries and petrochemicals also, you would see chemical engineers are in charge. Electronics manufacturing industries, I would give you a specific example. So electronics manufacturing firms, like I'm talking about firms like firms which prepare chips, who prepare semiconductor chips, like Intel, like Qualcomm. So these companies, it's not that they only recruit from circuital branches. It's not true. If you see the data of USA, and even in India, this has started recently. Many people who are actually completing their PhD, doctoral research in chemical engineering, they are getting recruited in these companies. If you take the data of United States, you would see that Intel, they recruit chemical engineers and also metallurgical engineers to a large extent every year. In fact, many of my batchmates, many of my juniors, they are employed at Intel. They did their PhD in chemical engineering, and their area was such that they are now working in Intel. I'd give a specific example on this semiconductor industry and how chemical engineers are relevant in it in one of the succeeding slides. Specialty chemicals and materials, specific chemicals. If you are trying to prepare some specialty chemicals, maybe some nanomaterials, maybe some specific agents, of course, chemical engineers are required to define the process. Environmental regulatory agencies, here also regulatory bodies, policymakers, they are also, the role of chemical engineers becomes very important. You would see that many of these state as well as national level environmental agencies, they employ chemical engineers. So they employ chemical engineering researchers, they employ chemical engineering graduates who have just done BTech, and the various kinds of job roles, job designations that are on offer for a chemical engineer, you can see, of course, chief executive officer is something that is a more like a managerial role, so I'll not get into it. But some designations like pharmaceutical engineer, quality control engineer, process maintenance engineer, production engineer. So as you suppose, some of you might be going for jobs in refineries, petrochemicals. So mostly you would be given either the designation of production engineer, or you would be given the designation of technical services engineer, that is process engineer. Apart from that, safety, process safety is also one aspect where chemical engineers are in huge demand. Not to forget the research and development engineer, because today's session is more about research and development. But it was very, I carefully kind of tried to include the industries where chemical engineers are employable, knowing fully that this is a seminar on research, chemical engineering research. The reason is, even people who have done their masters and PhD in chemical engineering, they are also employable. They also get jobs in these industries. It's not that when you pursue higher studies, when you do research, it's only that you become teachers, you become faculty members in institutions. Of course, many people prefer that because of the kind of job role, the kind of freedom, and the kind of exploratory freedom that you get in academia. But if you are someone who wants to work in industries, you want to do research and development in industries, you want to carry out innovation, for you also there are ample opportunities. But the thing, as in every field, that the important thing is that you have to be really good at it. Until and unless you are good at something, people would not be eager to hire you, because they would always find another alternative, another person who is more passionate about the work, who is more enthusiastic about the work he does, and that person would get hired. So if you need to strive excellence, you need to strive for excellence, no matter what area you choose, what area of research you choose. That was the reason I didn't want to include or discuss more about my specific area of research. If you have any questions, I'd be happy to answer. But then I thought it would be more pertinent to make you realize that no matter what area you want to work on, there are ample opportunities for you as a chemical engineer. And when I say that you have ample opportunities, I am talking it from the perspective of a researcher. That is, suppose you have done your master's, or suppose you have done your doctoral research, that is PhD in chemical engineering, you have lot of job opportunities. In industrial research and development in these industries. Okay, this slide is also something I am sure many of you are aware regarding this. So this is the list of the 17 sustainable goals of United Nations. And if you can see, many of these goals, these sustainable development goals, like zero hunger. So in order to meet zero hunger, in order to meet the objective of zero hunger, we need to achieve sufficient production of food. Only then the cost would go down, and we would be able to meet the governments in different countries would be able to provide sufficient food to the people, either through some rationing scheme or through some other means. But as I said, industrial production of ammonia made possible production of fertilizers in bulk quantity, because of which we are able to meet the demand of food for an ever increasing population. So zero hunger is definitely related to this is something that chemical engineers require active participation, so that this objective gets truly realized. Good health and well-being. These days, a lot of research in the biomedical industry. Suppose I can give you one example. Suppose you want to understand the drug formulation. You want to develop some drug, that is some medicine. You have decided on the formulation. That is, you have decided which compounds should come, which compound should come in this medicine, so that it can cure some disease. But just formulating, just choosing the compounds is not sufficient. The shape of the drug, the shape of the tablet, the size of the tablet, these things also play a big role, because ultimately in today's time, we talk about targeted drug delivery. Means, suppose a patient is consuming a medicine. So it's not sufficient that he consumes the medicine, but the medicine also needs to get absorbed onto his body. If you are consuming a medicine, but your blood is unable to dissolve it, it is unable, the digestion doesn't happen properly, the medicine is the key nutrients from that medicine are not getting dissolved in the blood, then the medicine would not give its impact. So this is very important. Not only that, suppose you consume a medicine now, but you don't want the medicine to act instantly. Or maybe you want that if you are consuming a medicine of, say, 10 mg composition, it should act in bits and pieces. Like 2 mg should first get released, it should get dissolved, then another 2 mg should get released. So this is known as controlled drug release. So these are aspects which a pharmacist or a chemist cannot solve. These are aspects which involves mass transfer. These are aspects which deals with fluid mechanics, because ultimately the medicine is flowing through your body. It is trying to get dissolved in the blood. The blood is flowing in your arteries and veins. So these are processes where fluid mechanics, where mass transfer are at play. And as you know, some of you, especially the ones who are in third year and fourth year, you have already studied subjects like transport phenomena, mass transfer. So you know the role that mass transfer and transport phenomena will have towards designing controlled drug release, towards designing targeted drug delivery. So medical research in today's time cannot survive without the active participation of chemical engineers. Clean energy, you all know about greenhouse gases, you all know about carbon dioxide emission, how to reduce it, and it is needless to mention that chemical engineers will have a key role to play here by developing suitable adsorbents, by developing suitable exhaust principles, by developing suitable gas cleaning mechanisms, and so on. And I can go on and on, but I hope you got the idea that sustainable, and for most of these, for achieving a majority of these sustainable development goals, chemical engineers' involvement is a must. Even for clean water, and sanitation, for water purification, the filters that you see, the Kent RO or AquaGuard filters that you see in your homes, essentially within that filter you have membranes. So that is a branch of research related to mass transfer, related to polymers. So these membranes that are there within your Kent RO or AquaGuard filters, those have to be specially prepared. Their design, their shape, their size, the way they are weaved, these things have to be decided after a lot of research, so that you can get the proper drinking water. No matter how your tap water is, you are getting a proper drinking water free from all impurities. So let me go for a specific example. As I was saying sometimes a few minutes back, a specific example related to manufacturing of semiconductor chips. So you can have the best of computers, the best of computing devices, mobile phones, tablets, and all that. But within each of these devices, it's not just the software, right? You need to have sophisticated chips. So it can be for your mobile phones, you can have a Snapdragon processor, or maybe something else. For your laptops, you might be having the ones made by Intel, the ones made by AMD. But these hardware, the hardware, these semiconductor chips, the manufacturing process has a lot of innovation. And you might be, I am sure you people must be keeping the latest trends that are developing. Qualcomm, the way Qualcomm is progressing. Recently, Intel, Intel was the market leader since long in the semiconductors, in the computer chip business, in the computer processing CPU business. But of late, Snapdragon is, that is Qualcomm. Qualcomm is really doing great. AMD is also picking up. Nvidia is another company which is doing a lot of work in the GPU sector, and a lot of it goes into innovating the chips, manufacturing the chips of, earlier it was 14 then it became 7 and a lot of research is going on how to reduce the size, how to have chips where you have very efficient heat dissipation. So these processes of efficient heat dissipation, these processes of polymer coating on the semiconductors, these are essentially chemical engineering processes. So chemical vapor deposition, or CVD as it is known, it's a classical method for chip manufacturing. Of course, there are many variations on this process as well, but chemical vapor deposition happens to be a very fundamental process which is used in chip manufacturing, and without chemical engineers you can't really develop this. And I already mentioned about the fact that chip makers like Intel, like Qualcomm, Nvidia, they recruit researchers in large numbers. And when I say researchers, it's not just people with software background, with computer science background, but also people having chemical engineering, metallurgical engineering, because these are the areas. I mean, whenever you are trying to coat a polymer over a chip, it's very much essential that you understand the process. Okay, so let me play the video. I hope it is visible.
Yes, sir, it is visible.
Okay, yeah. So here, as you can see, so basically in case of chemical vapor deposition process, what happens is that you have monomers. I believe you know what monomers are. So you have monomers, and you also have some compounds which are basically initiators. So initiators mean that basically they are initiating the polymerization process. So these monomers react in the presence of the initiator to form a polymer. These polymers are basically flowing in a vacuum chamber where you have the chip. And as these monomers flow, basically monomers get vaporized. So it can get vaporized. A liquid can get vaporized only when you are either decreasing the pressure or you are increasing the temperature. So that is a chemical engineering process. You have to suitably decide how to decrease the pressure or increase the temperature, at what rate you need to do, so that it gets vaporized and it enters the vacuum chamber. Again, at what flow rate it should enter the vacuum chamber, so that the deposition is proper, the deposition is a proper thickness, and that's how you develop the process. So this is just a very basic schematic, but it explains the process, that in order to have a desirable polymer coating over the chip, it's very much essential that we understand the process well. We are able to optimize the process parameters and design the process suitably. Okay, so let me play the video. Yeah, so here it depicts the cooling and the heating processes that are involved, because ultimately once the film of the polymer gets deposited over the substrate, over the chip, it needs to be cooled. And at what rate you need to cool, via what mechanism you need to cool, those things have to be decided only by a chemical engineer, because these are processes where simultaneous fluid mechanics, I mean mass transfer and heat transfer are at play, and also the polymer physics, because the way the reaction is happening, so reaction engineering is also involved here. So all these aspects of chemical reaction engineering, heat transfer, mass transfer, fluid mechanics, these aspects can be understood on a holistic scale only by a chemical engineer. That's the reason in semiconductor chip manufacturing you have a lot of chemical engineering researchers at play. So let us go to the next one. So yeah, now that we have understood the diverse applications of chemical engineering, the diverse industries where chemical engineering researchers are employed, now let us try to understand who should ideally do research. So if your knack is, I mean, if your orientation is more towards implementing the standard knowledge, the set knowledge that is there, because typically industries, I mean the process industries who manufacture something commercially at a large scale, they cannot do changes here and there on a daily basis, right? Because they have to standardize the process, they have to ensure that they are able to achieve a large scale production with the standardized process. So if your orientation, if your motivation is to serve that area, that you want to implement the already acquired knowledge in industries, then you are good to go as a graduate engineer. That is, after BTech in chemical engineering, you can join an industry, suitable industry, and you can do the work there. There also you have a lot of innovation. But when I say innovation, it's mostly I should say, you can suggest some changes, but ultimately getting those changes implemented in your process plant, getting those changes implemented in your industry takes a lot of time, because people would not believe in your ideas instantly until some certain research, certain pilot scale implementation has been done. So for people who prefer uh, implementation of previously acquired knowledge, for them after BTech they can suit. Of course, after BTech they can join suitable industries. However, people who are a bit creative, who are passionate towards developing new knowledge, of course, implementing previously acquired knowledge, knowing what is already done in the past is very important. But people for whom pushing the boundaries of knowledge is important, for creative, passionate, inquisitive minds, for them, a research career is ideal. And it's very difficult to understand a priori. For many students, I can understand that how do you realize whether you are fit for a research role, whether you are really meant for research, or you would not prosper in research. Again, that is very difficult to understand as a second year, as a first year, as a third year, or even as a final year student. But the point here is that I would come to it. You should make it a habit of developing curiosity. How to develop curiosity? It's a habit, of course. Some people are curious by nature, they have an innate nature of being curious. But then there is also a structured way, there is a structured way in which you can build on that curiosity, because it's not always possible that you have the same level of curiosity all the time. If you remember, if you see kids, you would realize that kids in general are very curious. They ask a lot of questions to their parents, to their elder brothers and sisters. But then as you grow, as you grow up in age, that inquisition, that passion to know the unknown, that gradually dies within us. But if you are someone who wants to explore the unknown, who really wants to have that, I mean, who has that kick whenever he knows something new, for such people, for such curious minds, research is really a suitable career to take up. Because, as I say, curiosity is basically the backbone of all kinds of research and innovation activities. Now the main point is how to inculcate this, how to inculcate and how to inculcate curiosity within us, and how to develop this curiosity. Of course, I do not know whether you would like this point or not, but this is really true, that you cannot ignore your textbooks. You cannot ignore the basic subjects that you are studying. Many a times I will tell you this true story, that researchers come, maybe they have the passion, they have the inner drive to do something. They are also ready to work hard, because research requires a lot of dedication. It's not that you don't enjoy the process, because people who work hard, now you see, I had classes. Today I didn't had class, but I had many meetings with my students, with some research activities I had. Even then I am joining this at 7 p.m. What do you think is the drive? It is the drive to engage with young minds, to discuss about the work, to to inculcate a spirit of discovery, or to inculcate a spirit of passion in their minds. That's what drives me to join with you in the evening. And it's true for most of the researchers, most of the people who are in this profession. So it's I mean, this hard work is not tough on us. It's not that we have to do it, that's why we are doing it. We really enjoy the process, and it is true for most of the researchers. But having said that, uh, no matter how hard you work, until and unless you have the fundamental concepts clear, you would be stuck at every point of your research. You might be very hardworking, you might be very enthusiastic, but until and unless you have the basic knowledge, until and unless you have the fundamental concepts, you would not be able to progress well in your research. So for that, I would definitely recommend, and since all of you are in your undergraduate now, mostly whoever is joining, please read the textbooks. It's not that you just refer to the class notes of teachers or just NPTEL videos. Those would serve as additional thing. But always make it a point. If you really want to do well, if you really want to prosper as a researcher, you need to study the textbooks. If you are studying reaction engineering, you need to study Levenspiel or Fogler. If you are studying, say, fluid mechanics, you have to study Frank White or maybe Fox McDonald, or whatever book is being recommended in your college. If you are studying transport phenomena as a subject, you have to study Bert Stuart Lightfoot. It's not that you study every page of Bert Stuart Lightfoot. It's not that you study every chapter of Bert Stuart Lightfoot. But whatever concepts that are covered in your class, those chapters, definitely you need to read from the book. And actually, as you read from the book, it's a journey. These books have been written with a lot of effort on part of the authors. So as you read through the book, you would also start enjoying the process, and then there would be no stopping actually. So the point is that you rely on textbooks, reference books, not just limit yourself to lecture videos and course material, that those class notes. Those are important, but you also need to see the books that would build on your concepts, and from there you can take up. I mean, you would have the groundwork ready so that you can progress further. Second one is to observe nature. This is very important. Observing nature doesn't mean that you have to bunk your classes. You have to, I mean, you say to your teacher that sir has asked us to observe nature, so you not go to classes. Not that. You might be going to your classes on a cycle from your hostel. Maybe you see something. Maybe you are seeing that water falls on a leaf, on a lotus leaf. As water falls on a lotus leaf, that is not wetting the lotus leaf. If water falls on paper, water wets the paper. But if water falls on a lotus leaf, it doesn't wet the lotus leaf. Why? Because lotus leaf is, as you know, hydrophobic in nature. But why is lotus leaf hydrophobic in nature? What all properties what all chemical composition lotus leaf has, what all factors lead to lotus leaf being hydrophobic? Paper is not, right? Paper, whatever is hydrophobic, water will not be able to wet it. But if something is hydrophilic, like paper is, water will wet it. Now, these has got a lot of applications, right? Many things you want as waterproof. So if you want something as waterproof, you need to have a hydrophobic coating on top of it. But you can draw, because many of these research, we call it as curiosity driven research. So you would see, if you visit the faculty, if you visit the websites of various researchers, faculty members, professors, you would see that some people write that I am a curiosity driven researcher. Means the idea with which his research activity span is mostly curiosity driven. Maybe it starts with some fundamental concept, some fundamental observation, and he is trying to explore why that is happening, and that is ultimately leading to some breakthrough, some discovery. So observing nature, observing the simple aspects, seemingly simple aspects. All of us know the story of apple falling from a tree. I'll not get into that, but it's not just about apple or something, but you have to observe nature, you have to observe your surroundings. And it's not just about observation, because as an engineer, as a person who is trained in sciences and engineering, you should be able to interpret it and also ask questions wherever possible. That is also very important. Thirdly, I would also say that since I mentioned this in the beginning, that how do you understand whether you have a curiosity whether you have a knack or whether you have that skill, that aptitude to do research. The best way to understand it is by doing research internship. I can share my own journey. I did internship right after my second year. It's not required that you do it right after your second year, but definitely after second year in the summers or after third year in the summers, it's very important. It will be very beneficial if you do some research internship, if you are thinking about higher studies, if you are thinking about taking research as a career. Because when you do a research internship, you get to understand what research entails, what research is all about, how research is done. And lastly, for developing curiosity, it's very important that you read the latest happenings. These days, reading is very easy, but it is also difficult, right? Because you have a lot of distractions. So if you are really focused, you can read about the latest happenings. You can read magazines, popular science magazines. You can read review articles. So review articles are basically articles, that is, those are research articles. Those are articles in research journals, academic journals, that review a particular area. So what happens, many of you might be new, these terms might be new to you. So what happens if you have a paper, particular researcher has done some work. So suppose I have done some work, I have found something new, and I would let the world know about it by publishing that work in some research journal. I would say that I have done this work, I have written what have I done, and you read it and you see, you study about it. This is one aspect. But many a times what is done is that suppose an expert in that field of research, he writes a review article, means he tries to understand. Suppose you talk about fluid mechanics, and within fluid mechanics, suppose we are talking about non-Newtonian fluid mechanics. So suppose a person writes a research paper reviewing the research that has happened in non-Newtonian fluids in the last 10 years or 20 years or 30 years. So that is a review article, because he or she is reviewing the work that has been done. Just like you do review of movies, review of OTT shows, it is also review of research papers. Okay, so review of original research papers is what is known as review articles. Reading review articles would be very beneficial, because see, most of you are undergraduate students, so it would be difficult for you to follow research articles right in the beginning. But review articles, perspective articles, these are different names for this same concept basically. Review articles, perspective articles, these would definitely give you a nice idea, a great introduction into the field. So in your area of curiosity, so you have to identify which fascinates you more. Is it fluid mechanics that fascinates you the most? Is it fluid mechanics transport phenomena is perhaps one of those fields where programming finds the most applications. But even in reaction engineering, even in thermodynamics, in all subjects that you have studied or you are going to study, maybe coding, programming has a lot of role to play. Now, the big question, if you are talking about, when I say that research internships are a great way to inculcate and develop curiosity, how to approach, how to get a research internship. This maybe many of you know, but still I thought of writing. Please do not write generic emails. Sorry to say, we get so many emails from students, prospective students from across the country that, sir, I want to really work with you. And just by looking at that email, we are in a position to understand that he has sent the same email to everyone, possibly in hundreds. That is easily understood because we are used to getting such emails. No, so then how do you write the emails? Of course, cold emailing also works. It's not that cold emailing doesn't work. I hope you understand what cold emailing is. Cold emailing means that when you are writing an email to someone whom you do not know beforehand. So that is what is known as cold emailing. That works. It's not that it doesn't work. But before you write to someone about a prospective internship position, it's very important that you have done some background research work. Research here means you have understood what he is working on. It's not just that you copy paste from his profile whatever research area is written. It's not that. I understand that as an undergraduate, it's not possible for a student to really understand what is written in the research papers. That's not something that we always ask for. But at least what we want is that at least he or she has made some attempt to read that paper, and he or she is trying to pose some question. The question is not very important, but the intent is very important. It always helps if you have some programming skills, because many a times what happens is that you people will you want to do internship for 1 month or 2 months, or even if it's a remote prolonged internship, even then it's very difficult to have you physically in the campus. So programming kind of skills, if you have, that is actually also beneficial for the faculty member, because then he or she can involve you in some part of the coding exercise. I mean, some part of the research which requires coding, that part you can do, because you would not be available in the campus all the time to do experiments. So it is always better if you pick up at least one, or if possible two, maybe C++ and MATLAB, or Python or MATLAB, or at least MATLAB. If you have some skills as a chemical engineer, then it always helps. Have adequate passion or experience to do experiments. If you want to do experimental research and not theoretical or mathematical research, then of course you need to have passion and experience. But then how do you develop passion? How do you have experience? It's often difficult for beginners. But at least if I mean, so even if you might not be having the you might be lacking the experience, but if the faculty member understands that you are very sincere, you are very hardworking, you follow the instructions, you are punctual, then he or she might allow you to do the experiments. Because otherwise what happens, teachers also, until and unless we have some confidence, we definitely we cannot be welcoming in that regard. This is very important. You show genuine interest, not by writing, not just by writing I really want to work, but you show that in action. So if someone has given you some internship position, it's very important that you do the work, you regularly have conversation, you actually get involved in the work. Because this point is something, it's very important, I'm telling you, because this is what happens in most of the cases, and that is the reason faculty members are not willing to take interns, especially BTech interns, because most of the BTech interns come not for gaining exposure to research. They are here for writing it as a bullet point on their CV. Believe me, of course you should write it on your CV. It's not that you shouldn't write it on your CV, but just writing it on your CV, just gathering a certificate would not help you in any way. Lots of us have many such certificates back in your physical folders or computer folders. That would not help. It's very important that if you have been provided a research internship, you actually do that work. The work doesn't end with securing a research internship. Securing a research internship is just 5% of the task. You actually do the internship, you do the work well. Because if you are sincere in doing the work, if you are passionate, if you are hardworking, I am sure majority of the faculty members would be more than willing to help you. But if they see that your only intention was to get a certificate, your only intention was to write it on the CV, then they feel very bad about it, because it is unprofessional as well, that they are devoting time to you, they are giving you some work, and after that you disappear all of a sudden. So that is something you should never do, and that actually has a very bad effect on your juniors as well. So suppose someone from a particular institute has done this with a faculty member in some institute. That faculty member from the next occurrences, he is very skeptical regarding taking another student from that institute, because he or she, that faculty member, thinks that if I take another student from that institute, maybe he will also be like the previous one, he will not do that work. So when you are doing such irresponsible activities, you are putting not only your reputation at stake, but more importantly, you are also putting the reputation of your institute and of your institute at stake, because of which your juniors might suffer. So please, whenever you are trying to get some internship, if you have been offered one, please take it seriously, please do the work. And that would actually help you, because you are here to gather the experience. Because if you do the research well, the advantage that you will have is that you will understand whether you are, you have that aptitude within you to do research, whether you are on the right track, whether it would be advisable for you to pursue a MTech or a PhD after that. So research internships are a great way to have that understanding. So please use it wisely. Please use it to your advantage. Okay. Along the way, of course, picking up relevant skills are very important, especially if you are doing programming and process simulation based research. Then these are some of the softwares that you might find helpful if you have idea. It's not that you have to be proficient in all of them, but definitely MATLAB is something that I must say all chemical engineers should be proficient in MATLAB. And apart from MATLAB, if you are able to pick up some of these, it would be really useful. But even if you are unable to pick up these before you join an internship or before you join a research career, along the way, you should be willing to pick it up. If you want to do experimental research, then you should be having, it's good if you have some experience. Even if you do not have experience, you should have that passion, you should have that aptitude, and you should also be good at analyzing results. Again, that will also come with experience. It's not that it happens in a day, but as I said, if you are, when a teacher is giving you some experimental work, he doesn't know, he is not aware regarding your experimental skills because you have not done such experiments before. Then how can he or she judge you? How can he or she assess your capability? Then some of the things that the faculty member would be looking for is whether you are sincere, you are punctual, whether you are hardworking, whether you are, whether you maintain time, whether you are organized. These things are very important, not just in experimental research. These are important even in theoretical research, in programming. But in experimental research, this is even more important because you have to deal with hazardous chemicals in many cases. You have to deal with high pressure apparatus in many cases. So it always helps if a person is hardworking, organized, disciplined, punctual. These things always help. Okay. Now, coming to the breakthrough. So we have talked about inculcating the curiosities. Now, if I want to talk about the breakthroughs, I don't want to desert any, but this is the fact that achieving breakthroughs takes time, often months, often years, sometimes even decades. That is how research works. But having said that, does it mean you need to work for a decade in order to complete your PhD? No, I'm not saying that. The idea that I'm trying to put here is that research career is more about the journey rather than always the destination. You might have heard this. This is a famous say. There goes a famous saying that success is a journey, not just a destination. All of us have heard that, and we mostly take it for granted, even without realizing what it truly means. But it's really true. You would be able to reach the breakthroughs. You would be able to taste the fruits of success only when you are enjoying the journey. Because breakthrough doesn't happen in a day or in 2 days. But if you are enjoying the journey, if you are enjoying writing the code, if you are enjoying debugging the code, if you are enjoying reading the books, if you are enjoying doing the derivation, that is what is important. That will surely help you in realizing the end, realizing the breakthrough. And since it's research, it's not possible for us to know beforehand how many days it will take. Of course, we have some idea regarding some of the activities, but in many activities, we do not have an idea how many days it will take. But that doesn't mean that the process is not enjoyable. Doesn't mean we become deserted, because we enjoy writing the code. If I'm a coding, if my skill is coding, I really enjoy writing the code. If I'm into experiments, I love to do the experiments. That is what is, that part is also enjoyable. Of course, I want the results, I want the breakthroughs. But even if the breakthroughs take a little longer to arrive, I am okay with it, because I understand that I am doing something which is innovative, which will take time. And when that eureka moment comes, when that breakthrough comes, that will make up for all the hard work that you have done over the last few months, few weeks. Sometimes it's weeks. It's not always that it's months. in many activities, when you are having something which is which is not that innovative, maybe it's just a small diversion from the routine work, then you will get it in 1 or 2 weeks, few weeks. Sometimes, depending on the extent of your innovativeness, depending on the extent of the innovation that you are trying to make, the discovery that you are trying to make, it takes time. But the journey is enjoyable. It's not that you lose you lose interest or you lose passion. That never happens, because you are used to the process. You enjoy the journey, and when you enjoy the journey, you do not think about destination all the time, and the destination, the breakthrough, the success is bound to occur. That is what has happened with us. We all have been through that journey. And maybe in the next slide, yeah. So do I have some more time? Maybe 5-10 minutes?
Yes, sir.
Okay. I'll try to wrap up in another 5 minutes, and then I'd be open to questions. So let me walk you through my own journey, because I think that would also help you in being able to relate and connect. So as I said, I did my undergraduate from Jadavpur University during 2009 to 2013. I was always interested in research in academics. I also did my internship, as I said, after second year as well as after third year. Both were research internships. Then I wanted to do industrial job, because frankly speaking, I have not seen the industry before that, because I didn't do industrial internship. What I did were research internships. So I decided to go for the industrial job, and I since I also got the job offer from Indian Oil Corporation, I decided to be there, knowing fully that I would not continue there for long, because I always had that. Because when I got exposed to the research internships, I really enjoyed the process. Every day was like a new day for me. Every day was like that spirit of discovery, that spirit of working hard on a problem, getting the results, no matter how minute that result is, no matter how insignificant that result could be. But actually, when you go through that process, when you start enjoying that process, that gives you a different kind of feeling, and no industrial job in the world can replace that feeling. So I decided, even though I got the job, I decided to work for a few days, for a year to be specific, because it's not possible, right, to leave midway. And as I leave, I need to take admission for higher studies, for masters in some other institute, and that will happen after another year. So I decided to discontinue. I resigned after 1 year. But I had a very enjoyable time at Indian Oil Corporation as well, as a production engineer. I was posted in the crude distillation unit. Crude distillation unit means the distillation process that you all know, where crude oil comes, and those are getting diesel, petrol, and LPG, and also you have the residues, heavy oil residues. So that operation, I was in that plant. I was working there as a shift in charge. So we had to actually control the various process parameters on DCS. So in industries, if some of you have done some industrial internship, you would know we have displays, computer displays, everywhere in a control room. So that's basically a environment under air-conditioned environment, where you have computers and all, and you have a computer, you can click and you can control various valves, you can control flow rates, you can control temperature, you can control pressure. These are the main things that you control. The objective is to ensure that the product that is coming out, that product is of desired quality. So if it's if it's petrol or if it's diesel, we have to be sure that the octane number, the cetane number targets are met. Density, viscosity of the products are also checked. So there are some operators in the field who check it on regular intervals, and they let us know whether the viscosity, what value of viscosity comes out, and we have to write it in a logbook. We have to maintain the records of everything. So after every 1 hour, after every half an hour, the viscosity, the density of the various products are collected, and those are tested, and we maintain a logbook. And also, as I said, our primary job is to ensure that the product specifications are met, and we used to control the temperature, pressure, flow rate in order to achieve that. So that was the job role I had. It was I had stayed there for 1 year. even though I left it because I wanted to pursue higher studies. But that 1 year stint at Indian Oil was really enjoyable. I had a lot of friends. I met the best of seniors. Some of them I am still in touch with, and it was really a nice opportunity for me to explore how a refinery works. In fact, as you know, Indian Oil is the one of the largest refineries. I mean, going by the refining capacity, Indian Oil is the largest corporation in India. Reliance comes after that, because Indian Oil's total refining capacity is above 100 MMTPA, that is million metric tons per annum. So I had a good environment. I enjoyed the work, but since I was drawn towards research and all, I decided to discontinue. I resigned, and then I pursued my higher studies. I decided to do it in India. So there is a confusion among students also in many cases whether to go for higher studies in India or abroad. I wanted to do it in India, although I had opportunities doing abroad as well. But I wanted to do in India because I always, this is again a personal thing. It's not that everyone has to do it in India or everyone has to go abroad. But the thing is, you should remember that no matter where you do your PhD, no matter where you do your master's, you have to be really good at it. This I mentioned even in the beginning. You have to be really passionate about it. You need to work hard. If you work hard, if you do it diligently and passionately, the country doesn't really matter. But of course, you have a lot of opportunities in countries like USA, UK. You have a lot of opportunities in India as well. It's not that you don't have suitable research opportunities in India. You indeed have a lot of research opportunities, especially in IITs and Indian Institute of Science. In these institutions, lot of research infrastructure is there, and if a person is diligent, if a person is determined, he can do as good work as in any other country, because the kind of research papers that we publish, the kind of research journals that we publish in, that are the same. Even, I mean, you can see the kind of research papers that comes out of IITs, the good labs, the people who are part. I mean, it's not that everyone does it, but majority does it today. That the kind of research articles that they're publishing, the journals that they're choosing to publish in, those are as good as the journals which their foreign counterparts from premium universities are publishing in. So it's not that we are sacrificing or we are diluting the standards in any way. It's the same, but of course, it's a personal choice where you want to work on. But no matter where you do your PhD, no matter where you pursue your research, you have to be really good at it. And in order to be able to be really good at it, you need to devote time. You need to be passionate regarding it. You need to be hardworking. This is another point. Maybe I should talk about it in 1 or 2 minutes. So research and startups. So where is the apparent similarity? See, as researchers, especially in academia that we are working as professors, our work is somewhat related to startups as well. I mean, the kind of work a startup founder does, our work is somewhat similar. Because the kind of job that we do, of course, we are salaried individuals, we are doing a job. But then in IITs, in other premium institutions, what happens is that we are being given a salary. Of course, we get a salary, and we get a lab space. That is some space that is given to us, and then the institute leaves us on our own. So the institute doesn't really interfere what kind of research I would do. The institute doesn't really interfere whom I will choose to do that research, which journals I will send those research papers to. So that is upon me. I have the freedom. It's not that they would monitor me every day in the morning. In the academic sector, you don't have that concept of boss. Okay, so that is also one of the reasons many people prefer academic research, that you don't have that kind of concept where you have a boss and boss supervisor who tells you what to do every single day. Of course, when you do your doctoral research, that time you have your supervisors, but as you land up in an independent position, you are on your own. So essentially, you are given a lot of freedom. This is the academic freedom that I was talking about. No one tells us what kind of research I should do. No one tells us, where I should get the funds from. So the funds that we do get from research, these are given by different funding agencies. Just like in case of startups, you have angel investors. Research. Of course, research requires So you have to write to various governmental and private agencies who would fund your research. Now they would not fund your research just like that. You have to, they need to believe in your capabilities. Just like a venture capitalist will not give you money just like that. Okay, so I mean, you know that, right? So they would assess your abilities, whether you can perform, whether you can make the best use of the money given to you. Similarly, whenever we apply for research grants, we write proposals. Just like you write a business proposal, we have to write a research proposal. So the agencies would assess that. There are juries who assess that, and based on our credibility, based on our past performance, and there is also some kind of a formal presentation, we are given funds. Then once we are given funds, they monitor our progress, but they don't micromanage us. So we have a lot of freedom in that aspect as well. So if you are someone who wants to have that creative mindset, who wants the safety net of a job, that is, you want salary every month, but at the same time you want to be on your own, you want to explore, you are hardworking, but you want to explore, you don't want someone to guide you at every step, then research career, academic research career is a perfect option for you. I thought of mentioning this because many students want to have a startup of their own these days, and it's definitely a good thing to have. Any good country for that matter, any developed country for that matter, has a lot of startups developed out of colleges, out of universities. But then in research career, academic research career that we have, it is also related to startups in a way. Not just that, even if you don't join an academic career, you can definitely do your PhD. And if you are really into startups and all, you can open companies based on your research. There are many successful examples even in the chemical engineering sector. I can name a company. There is a company named Technorbital. Technorbital is a company based in Kanpur. It was founded by a IIT Kanpur alumnus. After doing his PhD, he founded the company, and now their revenue is in several hundreds of crores. So that person did his PhD, but he was not interested in teaching or doing academic research. But he worked hard. He wanted to have a startup of his own. So this aspect also I wanted to touch upon, that research career can also lead you to being an entrepreneur by opening your own startup based on the kind of research, the kind of product, the kind of patents that you have developed in your PhD. Or you can choose to perform academic research, and even then, even as you pursue academic research, you get a lot of freedom. You have to write for your own funds. You have to decide what area you want to work on. So it's also similar to the work aspect of a startup founder. Okay, so here I end. It's already 8:20, past 8:20 in fact. So I'd love to have questions from you, and thank you all for the patient hearing.
Thank you so much, sir, for such a thought-provoking and insightful session. Your experiences and advice on building a successful research career are incredibly inspiring.
Yeah, thank you so
Move to
much.
the Q&A segment. Participants, if you have any questions, please feel free to type them in the chat box or use the raise hand feature to ask directly. So we have a lot of viewers watching this webinar on YouTube, and there are a lot of questions from their side as well. I would like to address the questions to you.
Yes, please go ahead.
So the very first question is so that is, are there any research opportunities in the field of forever chemicals?
In the field of
Forever chemicals.
forever chemicals.
Yes, sir.
Okay, forever means, is the question, I mean, if I've understood the question correctly, are they asking that are there research opportunities in chemical engineering forever? That is what the question is? Or
Yes,
Yes,
sir.
sir.
okay, yeah. So chemical engineering is a evergreen field. Okay, chemical engineering, if you see the traditional aspect of chemical engineering, traditionally chemical engineering was all about oil sector, right? Oil, gas. So you have these behemoths like ONGC, like GAIL, Gas Authority of India Limited, Indian Oil Corporation. So at one point of time, these companies Of course, actually, these are the backbone of our economy. Until and unless you produce oil, you cannot run an economy. Now, many of us know that world is transitioning towards EV, electric vehicles. So does that mean chemical engineers would lose jobs in large quantities because fossil fuels would be out of order? This is not true, because firstly, it will at least take another 50, 60 years, if not more, for these fossil fuels, for these oil and gas resources to get exhausted. Secondly, if you see the electric vehicles research, the kind of EV sector, the way EV sector is developing, if you look into any EV company for that matter, be it Ola, be it any other, I don't want to name any specific company, they hire a lot of chemical engineering researchers who have done their PhD in battery research, battery development, because electric vehicles, the main thing in electric vehicle is battery. The core component is battery. And for developing the most efficient batteries, which can dissipate heat faster, which can hold charge for a faster time, you need chemical engineers, you need process engineers. So this is just an example that chemical engineering is all about what? It's about process engineering. Whenever you have process, as long as processes will be there to operate an industry, chemical engineers would be required. And that is definitely not going to get out of order. Of course, the wave will change. Now the focus is more on oil and gas. Maybe in the next 70, 80 years, the focus will be more on electric vehicles, or maybe even before that. But chemical engineers who have strong knowledge in the fundamental aspects of reaction engineering, transport phenomena, process control, I mean the thermodynamics, which governs chemical engineering processes, they will never be out of job, or they will never have a problem. I hope I have been able to answer your question. No?
Yes, sir.
Okay.
Sir, the next question is from Gaurav. So the question is, how to decide upon a topic for further research career when there are so many fields and all fields are so diverse?
Correct. So this is a very useful question, and I'm sure this question might have occurred in the minds of many of you. So the thing is, it is very difficult to decide a priori, okay? Because as a student, as a second year, as a first year, as a third year, as a final year student, how do you decide which would be most interesting for you? But the thing is, it's not really required that you focus on the topic. I will give you an example. Suppose you are seeing that lot of activities are going on in the carbon capture these days. Lot of activities are going on in the hydrogen generation, green hydrogen, blue hydrogen, these things. So a lot of work is going on in the biomedical sector, in the health sector, drug delivery and all. So how do you understand which one interests you the most? I would say it is not required, because the fundamental processes governing these seemingly different applications are the same. If we talk about carbon capture, how is carbon captured? Either it would be through an adsorbent, or it would be through some other arresting mechanism, where you would have mass transfer, where you would have chemical reaction engineering, and these aspects. If it's about battery development, when you talk about battery development for EVs, of course, whenever you design batteries, one aspect is, of course, the synthesis of that battery. So making of that battery, in what sense? That what all chemicals should go into the making of battery. Is it sodium ion? Is it lithium ion? Is it something else? That is a one aspect. But that is not the entire thing. It can also be about heat transfer dissipation in batteries. So what I would suggest to the students, don't be focused on the application area where you want to work. Instead, it would be better if you focus on the relevant skills which interest you the most. Are you more interested about reaction engineering? Are you more interested about fluid mechanics? Are you more interested about process control? Are you more interested about thermodynamics? You decide on that first. Do you like to code? Are you fond of writing programming? I mean, doing coding? Or are you more fond of doing experiments? You decide on that. Once you decide on that, you develop the skills on this. You study that subject very well. You develop coding skills very well. If it is about experiments, you try to do experiments wherever you get an opportunity. The specific application area can always be decided later, because that would change. And in fact, I can give you my example in this regard as well. As a class 12 student, I didn't have biology because I was not fond of biology. I got decent marks in biology. I got good marks, but I never enjoyed biology as a subject. So I had physics, chemistry, mathematics, and computer science in my class 11. But now, if you see my research profile, I also work in the area of biological fluid dynamics. I try to study how blood flows in vessels. Because, I mean, why I am able to understand that? Because I am using the fundamental principles of fluid mechanics. I'm trying to understand mass transfer. And I mean, in using the fundamental principles of fluid mechanics and mass transfer, I am trying to understand how blood flow occurs within our bodies. So this is the thing. You try to focus on the fundamental subjects which interest you the most. You try to focus on whether experiments you like, whether coding you like. You try to develop those skills, and the rest part you will understand in due course of time. Never, I mean, it's not at all required to worry about it. If I can work in the field of biology at this age, I have started it just recently, 1-2 years back. If I can do it, you can definitely do it. Yes. Next question.
So there are a lot of questions incoming, but due to shortage of time, we cannot address all them.
Sure.
Thank you, sir, for patiently answering all the queries and sharing your such insightful thoughts.
Yeah. Thank you, Roshni and Harshit, and all the people who have assembled over here. It was really nice interacting with all of you and answering your question. And it also gave me an opportunity to look back look back at my own journey as a student and as a researcher over the last few years. Thank you all.
Sir, now we would request Assistant Professor Dr. Ashok sir to take over from us and deliver the token of appreciation to our prominent speaker.
Okay, thank you, Rosni. Good evening, everyone. Good evening, Professor Sourav Sengupta.
Yeah.
I
Good
am
evening.
Dr. I am Dr. Ashok Kumar Barnwal. My PhD was from IIT Kanpur, and my research field was also same, related to fluid mechanics and heat transfer transport phenomena.
Yeah.
So it is truly an honor for me to deliver the vote of thanks for this enlightening session. On behalf of the Chemical Engineering Society, I extend my heartfelt gratitude to Professor Sourav Sengupta for taking the time to join us today and sharing his invaluable insights on building a research career in chemical engineering. It is really truly uh, fruitful for us, sir. Your words have been both inspiring and thought provoking. The way you unraveled the journey of research from curiosity driven exploration to impactful discovery has given us a fresh perspective on what it truly means to be a researcher in this ever evolving field. Your ability to connect fundamental ideas with real world applications has not only enriched our understanding but also motivated many of us to pursue research with greater enthusiasm and purpose. We deeply appreciate your willingness to share your knowledge and experiences with us. Your session has undoubtedly sparked curiosity, encouraged critical thinking, and provided invaluable guidance to all the aspiring researchers present today. I would also like to thank our attendees for their active participation, making this session interactive and engaging. Lastly, I would like to extend my heartfelt gratitude to our speakers for illuminating our success. Once again, thank you, Professor Dr. Sen Gupta, for your time, expertise, and invaluable contribution to this session. We sincerely hope to have more opportunities to learn from you in the future. And I want to be in touch with you, sir.
Definitely.
And also, I hope from our student side, if students need needs to clear some question and doubt regarding this subject, especially try to be in touch with Professor Sengupta. It is nearby us.
Definitely, definitely. Thank you, Professor Baranwal. It was great interacting with you all, with the students and with the faculty members of BIT Sindri. Definitely, we are very nearby, and I would definitely love to. I would be very happy to interact and address any other queries if the students have. They can also write an email if they have any follow-up queries. I'd be more than happy to answer. And I would also love to visit your campus physically in the near future if time permits. Definitely.
Thank you, sir. Thank you, sir.
Thank you. So, should I disconnect now?
Yes, Rosni.
Sir, now I would like our team to present our token of love to Sourav sir.
Thank you. Thank you so much. Thank you so much for the warm gesture.
Okay, Rosni, is this session over?
Yes, sir. Thank you so much, sir.
Yeah, and I would also like to thank Roshni and Harshit for patiently and very professionally conducting the session. And I hope it was of some use for the students who have assembled. And if this session has been of some help, and if this has sparked at least even a small spark of inquisition and inquiry in you, I'd be very happy to see at least some of you from this session, whoever has been present today. I'd be very happy if I hear maybe 10 years, 12 years, 15 years down the line that some of you have indeed taken academic research and have prospered in it. Thank you all.
Thank you,
sir.
Yeah, thanks.
May I leave, Rosni?
Yes, sir. Thank you, sir.
Thank you. Thank you.
We would also like to thank our enthusiastic participants for joining us today and making the session interactive and engaging.
We hope this session has inspired you to embrace curiosity, pursue excellence, and make meaningful contributions in the field of chemical engineering.
Thank you, everyone.